All right, today we're going to be going over a new topic, Essential Learning Target 3. The big idea for this topic is that we can solve equations by completing the square. So Essential Learning Target 1 was that we could solve equations by factoring. This is we can solve equations by completing the square. So let's do our first example. It's going to be the only one that we have time for today. So example 1. And let's write it out. We've got 6, oops, let's make it blue. 6x squared minus 48 equals negative 12x. Okay, the first thing we want to do is to see if we can reduce these coefficients. So these numbers they're not huge numbers, but we want to see if we can maybe make them smaller, just because smaller numbers are easier to work with. So we want to look and see if we can divide them all evenly by a number. Are they all divisible by a number? And the answer is they are. Right. They are divisible by 2, and they're also divisible by 6. So I'm going to divide them by 6 since that's going to make them even smaller. So that's going to give me x squared minus 8 equals negative 2x. So let me describe what I just did. We check to see if the coefficients can be made smaller by division, which we did. Okay, the next thing we want to do is we want to use algebra, and we're going to move all of the x's to one side of the equation. So the way I'm going to describe this is we're going to make sure that the quadratic term and that the linear term are together on one side of the equation, and that the quadratic term should be positive. So if you're unfamiliar with that vocabulary, okay, this is the quadratic term and this is the linear term. This is technically called the constant term, but since we're not dealing with it, I'm not going to be too concerned about that. So this is a quadratic term. And this is the linear term. Okay, and what these terms are describing is the exponent on the exponent on the independent variable. So because this quadratic term has a exponent of 2, that's what makes it quadratic. So quadratic term because of this exponent. The linear term is an x, but it does not have any exponents. So we want to move all the x's to one side. Since this is the quadratic term, we want to keep it positive. So we don't want to move this one over here. We're going to move the negative 2x over here. So we're going to add 2x to both sides. Like so. Okay, and that'll go ahead and zero out these on the left or on the right. And we're going to have x squared plus 2x minus 8 equals 0. So what was this step? We use algebra to move the quadratic and linear terms to the same side of the equation, and the quadratic term should be positive. Okay, the next thing that we're going to do is we are going to complete the square. So let me just type this in. Okay. So completing the square means, so when a square polynomial, or I should say a square trinomial, or a square quadratic, let's put it that way. That's the best way to say it. So a square quadratic is usually made up of 3 terms. Okay, so you'll have your quadratic term, your linear term, and then some constant term. Okay, so you need all 3 pieces to complete the square, to make a complete set. Now, the third term, which is the linear, or I mean the constant term, is very specific. It has to match with the quadratic and the linear. So this -8 actually does not go with the x squared and the 2x. We need to figure out which number does go with that. So I'm going to do the box method here, and I'm going to show you how we can figure that out. So I'll just draw a little box like so. Okay, and we'll begin to place these appropriately. So this is x squared. Now, the way the box works is we factor out x squared. So in other words, what times what equals x squared, right? So what times what equals x squared, and that's going to be x times x. So we're going to go ahead and put x and x here. X and x. And this works because x times x equals x squared. And here we have a 2x, so we're going to split that up here and here. Okay, and the question is, 1x is what times what, right? Like blank times blank equals 1x. Well, we already have an x here, right? So it's something times x equals 1x, and the answer is 1. So now we have 1 times x, and that gives us 1x. Okay, we're going to repeat the process here. We already have an x, so we need something here, and that's going to be a 1. So x times 1 equals 1x. All right, and that lets us figure out what goes here. So this is going to be 1 times 1, right, which is 1. Okay, and this is the constant that we were looking for. Okay, so what goes with x squared and 2x, we need a 1. Okay, x squared, 2x, and 1. So what we're going to do is we're going to make sure that there's a 1 in here. There's a couple of ways to do that. You can either add 1 to both sides. Okay, that'll work. Or you can take 1 away from the 8, from the -8, and that allows you to put it over here. Both of which are valid. Okay, but there needs to be a 1 here. So let's go ahead and write that. So we're going to do x squared plus 2x plus 1, right? We need this 1. Put -8 equals 1. And this is x squared plus 2x minus, or plus 1 minus 9 equals 0. Okay. So either one of these is correct. There's not one that's better than the other. They're useful in different ways, but you want to at least have the complete square. We're looking for this set of 3. So let's go ahead and write this. Either of the above equations is correct. One is not better than the other. Okay. What we're going to do next is we're going to use algebra, and we're going to move everything that's not our set of 3. We're going to move it to the other side. So our set of 3 is going to stay together, and then everything else gets moved to the other side. So we're going to use algebra to move everything except the trio of terms to the other side of the equation. So if you were working with this one, right, you would add 8 to both sides like this. So that would cancel the 8s. Or if you were over here, you would add 9 to both sides. Okay, either way, the next step is the same, which is going to be x squared plus 2x plus 1 equals 9. X squared plus 2x plus 1 equals 9. All right. What we're going to do next is we are going to replace our set of 3. Okay. So our set of 3 represents the interior area of this square. Right. So x squared is here. Right. 2x is here. And 1 is here. So that represents the interior area of the square that we completed. We're going to replace these terms. We're going to replace this trio. We're going to get rid of it entirely. And instead what we're going to write is we're going to write the length times the width of the square. So we're going to get rid of all of this. And we're going to write the length times the width. So that's going to give us x plus 1. That's the length. Times x plus 1. So we're just going to put a squared. It's going to equal 9. Okay, I'm going to go ahead and color code this. So the length and the width are here and here. And that's what goes here. Okay, now what we're going to do is we can actually begin to use inverse operations. So if we have x plus 1 squared equals 9, we can take the square root of both sides. Let's extend this out. Okay, why do we take the square root of both sides? It's because we're going to begin to use inverse operations to isolate the x. That means that everything that is with the x needs to get canceled out, right? We're looking to isolate it. So the only thing that should be on the left-hand side is just the x. So all the extra stuff needs to be canceled. That exponent of 2, we can cancel it with a square root, right? As we learned in the previous target, the square root cancels the exponent of 2. So this cancels this. All right, and that's going to give us, and this will turn into a 3. So that's going to give us x plus 1 equals 3. Let me go ahead and write this here. Use inverse operations to isolate x. Okay, now there's another issue as well, okay? If I solve this right now, right, so I can subtract 1, and that's going to give me x equals 4. Okay, the issue is that this is only one solution. And if we look back at the original problem, we should have 2 solutions, right? The fact that we have an exponent of 2 on the x means that we expected to get 2 solutions, but here we only have 1. So what gives, right? What happened? Well, what's happening is as soon as you cancel out this exponent of 2, you're eliminating one of the solutions, right? So even when you go here, right, when you look here, this technically still has 2 solutions. But as soon as you get rid of this square, it goes down to 1 solution. So how do we deal with that? Well, when we cancel the exponent of 2, we need to do something to make up for the fact that we got rid of a solution. So what we're going to do is we're going to make 2 equations like so. X plus 1 equals -3. We can subtract 1. And then that gives us, did I say 4? My mistake, students. 3 minus 1 is not 4, it's 2. And then this equals -4. So let me go ahead and type this here. When you cancel, oops, let's go ahead and do this. When you cancel the exponent of 2 while solving, make sure to keep track of both solutions by having a positive, and negative version. Right? So this is +3 and this is -3. And then these are your 2 solutions. All right, and that is how you solve by completing the square.